taught until page 109. So we go to page 109. The coordinate system in OpenCV. To show you the coordinate system on OpenCV and how to access individual pixels, we are going to show you a low resolution image of the OpenCV logo. So we have this image. This is a logo of the OpenCV. This logo has a dimension of 200 by 18. 20 times 18 pixels. That is, this image has 360 pixels. The result of multiplication, this multiplication, 20 times 18. In every following image. So 20 pixels, the first one, you see, this is the width of the image. In the horizontal dimension, we have 20 pixels. And 18 is the number of rows. This is the number of columns. This is the number of rows. So the number of columns is the first one. Okay? Now we are going to look at the indexing of the pixels in the form XY. Notice that pixels are zero indexed. Pixels are zero indexed, meaning that the upper left corner is at 0, 0. So the pixel in the upper left corner, its coordinates, its coordinate is 0 and 0. It's not 1 and 1 because it's zero indexing. Indexes are started from 0. Take a look at the following image, which indexes 3 individual pixels. So the first one, remember that the first number is the number of columns, or we can say X axis. We can remind it like this. So this pixel, the coordinate of this pixel is 0 and 0. For example, here 8, 0. So this is the first number is the number of columns. So it is 8. You see, it is the same row. This pixel coordinates of this pixel are 8 and 7. So the second number is the number of the row. Okay. The information for an individual pixel can be extracted from an image in the same way as an individual element of an array is referenced in Python. In next session, we are going to see how we can do this. So this is 0 and 0, the first number, and when we go right, the first number increases, and when we come from up to down, the second number, which is the row number, is increased. Okay, the voice is low. The voice is low. Let me increase the better now. Is the voice better now? If the voice is good, now I increase the level. If it is good, please send one. Okay, nice, thank you. So the next title is accessing and manipulating pixels in OpenCV. In this section, you will learn how to access and read pixel values with OpenCV and how to modify them. Additionally, you will learn how to access the image properties. If you want to work with many pixels at a time, you need to create a region of image or a region of interest. I will explain it. In this section, you will learn how to do this. Finally, you will learn how to split and merge images. There is a tip here. Remember that in Python, images images are represented as numpy arrays. Therefore, most of the operations that are included in these examples are related to NumPy. So a good understanding about the NumPy package is required to both understanding the code included in these examples and to write optimized code with OpenCV. Okay? So we will explain about NumPy. So the next title is accessing and manipulating pixels in OpenCV with BGR images. Now, okay, I will send the link on the link of the video of this session in LMS after the course. Okay, after the session. So now we are going to see how we can work with BGR images in OpenCV. OpenCV loads the color images so that the blue channel is the first. In OpenCV, blue channel for a color image. For a color image or the color images, the first channel is blue, the green channel is the second, and the red channel is the third. Okay. If I will send the link of the whole video of session after finishing the session in LMS. Okay, so don't worry about the sound. So don't worry about the sound. So let me continue. Please see the accessing and manipulating pixels in OpenCV with grayscale images section to fully understanding this concept. First, read the image to work with using the image read. Let me that I run Spider. So to read an image in OpenCV, we use cv2.imageRead function. This is the function that we use. Okay. The image should be in the working directory. The image should be in the working directory, or a full path to the image should be provided. So when you write a program, the program is in some directory. So we say to that directory the working directory. When you run the program and read an image, that image should be at that directory, the same directory that our program is. But also you can provide the full path of the image. If it means that if the image that you want to read, it's not in the same directory as the file, as the program is. So there is an example here. In this case, we are going to read the logo PNG image and store it in the img variable. So if we want to read an image and save it in a variable, so we give a name to the variable and then we say cv2image read logo.png. After the image has been loaded in img, we will gain access to some properties of the image. So each image has some properties. For example, the first property we are going to extract from the loaded image is shape, which will tell us the number of rows, columns, and channels if the image is in color. If the image is in color, we also have the channels. But if the image is not color, it's a grayscale, so this is we don't have channels. We will store this information in the dimension variable for future use. So let me run the program. So here I wrote the program last session. Let me run it. F5. Oh, okay. You see this program that I wrote in the previous session read an image from this directory, the image cat.png. It's from chapter 5, okay? If I go to chapter 5 of the code, you see this is the cat PNG. If I right click on it, and then properties, details. So this is an image with 300 pixels in row and column. So I close it. I wrote this if for any reason. Maybe we can't read the image successfully. So, for example, I write here cat1 cat1.png. So we don't have this image in that directory. So if I run it, so it issues an error. You see, it issues an error that because we try to show image show. Image show is for showing an image. We read the image and save it in the variable img. If the image is not there, or we write the name incorrectly, or for any other reason, maybe the image is not read successfully, so img will be none. Img will be none if the reading of the image is if the reading of the image fails. So then when we try to show the image, it issues an error. You see, it says that in line 15 is this image show. There is an error. It says that assertion failed, size width. Okay, there is an error. The error is that it couldn't read the image. Why? Because I wrote its name incorrectly. So if I remove the 1 again, we press F5, or I click run, and the program executed, and it can show the image successfully. So also we can select another image, for example, cat-face.png. So let me copy this. So Control V, cat face. So I change the variables to image1 and image2. So if image1 is none, so here I show image1, and also I can show another in another window. I name the window 2 and say show the image img2. Okay, so if I run it now, you see we see two images. The caption of this window is 1, the caption is of this is 2. Okay, so I click. You see the windows stay open. So if we want to close them automatically, we can call destroy all windows. So I run it again. So it shows images. Now the program is here, the running of the program on CV wait key 0. It waits that we press a key on the keyboard. So when, for example, I click enter, then it reaches to this command, to this statement, and this statement destroy all windows. Okay, it closes and destroy all windows. So okay, wait a second. Oh, we when there is an error in reading the image, then maybe image 1, for example, img1 is none. So we can exit from the program immediately. So for example, I write import sys, then sys exits. Let me run it. For example, I put a G here, then the first one is. You see, now I wrote the path of the first image. I put an error here. Okay, so it's the first image read can't read the image successfully. So img will be none. img1. If I write img1, oh, it's none. It doesn't show anything. So then when we say if img1 is none, so it's correct then it prints error, and with this statement sys.exit, program stops, the running of the program stops, or we exits from the running. So the other parts of the code don't execute. If you don't do that, then it will issue an error. So for example, if I put a if I set this line to comment in Python, when there is a hash on beginning of the line, it's a comment. It means that it doesn't run. So if I don't put sys.exit here, and when img1 is none, because it couldn't read the image, it's unsuccessful, img1 is none, so it issues an error. You see, it issues an error. But we don't want that program exits by an error, so we control it. We say that if I remove the hash, so program. So if for any reason we couldn't read the program couldn't read the image successfully, then this condition will be true, and then it prints, for example, error in reading img1, and then by sysexit, execution exits from execution stops. Okay, so I run it again. So this issues this error. So if I make it correct again, so you see there is no problem. Okay, if the sound is cutting, I put the video on the elements. Okay, I can't do anything at the moment. Problem in my site. Oh, wait a second. Okay, now it's better. It sounds good at the moment. If it's good, please send plus or 1. Maybe. Okay. So there was a question. There was a question. What is CV2 weight key? Okay. I explain to you it using the documentation of OpenCV. Wait a second, that Firefox runs. Then I open the documentation of OpenCV, then I explain to you. No video. Oh, okay. You should wait a bit. Okay, you see the desktop or no? Okay, so I open the so this is the weight key in documentation of OpenCV. It waits for a pressed key. The function wait key waits for a key event infinitely when delay is less than or equal 0, or for delay milliseconds when it is positive. Okay, so when we write here wait key 0, the argument is 0, it waits infinitely for pressing a key. Why? It's before image show. So because if you don't put it, if you don't put this, I convert it to a comment, I run it. You see, the images are displayed, but they are closed immediately. So to change it, that we have enough time to see the images, we put cv2.wait 0. So when we run it, so you see, the images are displayed. We see them. The execution is here now in cv2 wait 0. It waits for a press key. So if I press a key, for example, an enter, then it goes to the next statement. Of course, this program returns a value. You see, wait a second, I'll show you. I should say that this delay can be positive. Okay, I should say. For example, you say that wait 1000 milliseconds. It means 1 second. And if I put a positive number here instead of 0, it waits. For example, here it's 1000, then it waits 1000 milliseconds. If it is 100, then it waits 100 milliseconds. But if it is 0 or minus a negative value, then it waits infinitely. So if I put 1000, I run it. So you see, it closed automatically because it waited for 1 second, 1000 milliseconds. If we don't press any key, then it goes to the next command, to the next statement. So if I print ch, you see, enter. So you see, it writes the code of that character. Okay. But normally we don't save the return value. Okay. If we need it, we can use it. But if we don't need the return value, so it returns the code of the pressed key. It returns the code. You see, delay in milliseconds, 0 in the special value, that means forever. Okay. So let's come back here. Note that I put an R here before quotation. If I remove this, then there will be an error again. You see, it can't read the image. If we want to read, what is the reason why it couldn't read? Because for each backslash we should put 2 backslash. Backslash is a special character. So in a string, I mean between quotations, each 2 backslash considers 1 backslash. You see, then it's not. Okay, but we can put still 1, but we should put an R here. When we put an R here before the quotation, we say that consider this string as is. Consider the string as is. So if we put an R before a string in Python, it means or it says to Python, consider it as is. Otherwise, i.e. Without any R, we should put 2 backslash instead of 1 backslash. Okay. Okay. So we are still should should put another if here, or we can here, or img2 is none. We then change it. Error in reading image 1 or image 2. So if we put a mistake here, then I run it. So when it reaches here, the condition is true, and the program, this print is run. You see, error is reading image 1 or image 2. This print executed, and then by sys.exit, we exit from the program immediately. So if image 1 is none or image 2 is none. For example, maybe we have a mistake here. So again, it's the case. But if there is no error, then we don't have any problem. Normally we put 0 here. So it waits forever. It waits forever to press a key. So when I press a key, it stops. It finishes the program. From this command and reaches this statement or command, then yes, all windows will run and all windows are okay. Let me come back here. Oh, we wanted to talk about the shape. So I write print img1 dot shape equals img1 dot shape. Also we do it for image 2. Oh, what happened? Control C, Control V. So image 2, I run it again. So it waits here. I press the key. So you see, image 1 shape is 300 by 300 by 3 channels. The second one is this. Okay. No sound again. I think you should have my sound at the moment because my connection is excellent now. If you hear me, please send a plus if the sound is good. It's pretty good. Good. Okay, thank you. So the shape says us. I show you how you can find it. Okay. In NumPy, shape of array. Shape of an array. You can find this in NumPy or std. So for example, if you have an array like this, in NumPy its shape is this. Okay, it's not enough here. Anyway, the shape tell us the number of rows, columns, and channels if the image is in color. But maybe image is not in color. I changed the first one a bit. Let me change the second one. Control C, Control V, img3. So if I put a 0 here, I add comma 0 here. What will be? Well, what will happen? So I write this. I show image 3. So I name the window 3. You can put anything here, okay? The name of the window. So I print the shape of the image 3 as well. Image 3. So you see what happens. Image 2 is this. It's a color image. When I add the 0 at the end of the image read, it reads the image in grayscale. So you see, you see now, it doesn't, the image 3 shape doesn't 3 on the end. So if the image is grayscale, then we have just the width and height, the number of rows and columns. Okay. Okay. Okay, dimension. You see, in book, it saves img shape in dimensions. In the book, the variable name here is img. In my program, it's img 1, 2, or 3. Okay. Its name. So we can save the image shapes. Let me Control C here, Control V. For example, I write D1 equals this. Okay, I can save. img3. Oh, where is it? D3. In the book, it stores the shape of the img in a variable with name dimension. I save them in D1, D2, and D3. Then we can put here D3, D2, and D1. Okay, I run it again. You see, same thing happens. This program, I will send it. Why not? Why not? Save it. Let me write here scripts. Why in PDF? In high it's better. It's not good. Let me check if there is a PDF here or no? Do you see PDF here? I don't see a PDF here. I can send it in file that you can have it. I will send it, okay? Let's continue here. After the image has been loaded in img, we will access to some properties of the image. The first property we are going to extract from the loaded image is shape, which will tell us the number of rows, columns, and channels. If the image is in color, then it has channels. We will store this information in the dimension variable for future use. So you see these lines are comments, okay? But this one is the statement that saves img shape in dimension. Also, another property is the size of the image. Img size is equal to the multiplication of height times width times channels. So this is the img size. It saves in a variable with the name of total number of elements. Okay. The property image D type is obtained by img D type. In this case, the image data type is uint8. It's 8 bits, and we save 0 and positive numbers, unsigned characters. So it can. So what is the range? I explained in the previous session. The range is between 0 and 255. So each pixel can be a number between these two numbers. So we have D type as well. So I can here write img1 D type. So you see D type uint8, or img2. Again, it's uint8. We can also write here to print it. We can write, for example, we say img D type saves it in image underscore D type. To display an image, we will use the CV2 image show function to show an image in a window. The window automatically fits to the image size. The first argument to the function is the window name, and the second one is the image to be displayed. In this case, since the loaded image has been stored in the img variable, we will use this variable as the second argument. So this is image showing the book. So the name of the window here, the caption of it will be original image. After the image is displayed, the CV2 wait key function, which is a keyboard binding function, will wait for a specific number of milliseconds for any keyword event. The argument is the time in milliseconds. If any key is pressed at that time, the program will continue. If the number of milliseconds is 0, it means that we write it like this. It will wait indefinitely for a keystroke. Therefore, this function will allow us to see the display window waiting for a keystroke. So you see this function will allow us to see the display window waiting for a keystroke. So we write CV wait key normally after image show, that we have enough time to see the to access a pixel value, we need to provide the row and column of the desired pixel to the img variable, which contains the loaded image. For example, to get the value of the pixel, this pixel that code its x is 40 and its y is 6. We use the following code. You see, img 6 and 40. So we can write in program, for example, B1 for BGR equals img1 For example, 6 and 20. Okay, so then we can print B, G, R. So I run it. So this is B, G, and R. Okay. Oh, very good question. Hello, Hassan Mohaysen. I will answer to in a second. Okay. Image size. There is another question. What is the difference? Or you should say what is the difference between img size and img shape? Shape is size is a number, but shape is 2 or 3 numbers. Okay, shape says us the number, how many columns, how many rows, and how many channels we have. So it gives us 3 numbers for a color image. For a grayscale, it gives us 2 numbers, the number of columns and the number of rows. But size is the number of all pixels. Okay, I show you again here. If I find shape, so shape tells us the number of rows, columns, and channels if the image is color. Oh, you understood? But the size is equal to multiplication of height, width, and channels. Okay. So if the image is in color, and we say that show the number, the pixel in this coordinate, then it gives us 3 values, because in each pixel we have 3 values: B, G, and R, blue, green, and red. So we have loaded the 3 pixels values in 3 variables BGR. You can see here that OpenCV uses the BGR format for color images. Additionally, we can access 1 channel at a time. In this case, we will use row, column, and the index of the desired channel for indexing. For example, to get only the blue value of pixel, we would use the following code. You see, 6, 40, and 0. Then we will have 1 number. It's just blue. If we want the green, then we put this number, we set this number to 1. If we set this number to 2, then it will be the red channel information. So the pixel values can be also modified in the same way. Remember that it is the BGR format. For example, to set this pixel to red, perform the following. You see? So I copy this. Before showing the image, so let me change it. So colon means that I check this, for example 20. So in image 1, so you see a line here. This is the red line. These pixels, the first value is 20. So the first value is the number of row. Okay? Number of row. The first one is the number of rows. Why? Because actually images are numpy arrays. In OpenCV, images are numpy arrays. The first number is the row number, or we can say y, because y normally is the row number, but in OpenCV functions, the first number in indexing, I should say, in indexing, in OpenCV, when we just in indexing, images are numpy in indexes in numpy arrays. The first number is the no number, but in OpenCV functions, you see, look here there is no OpenCV function. You see, it's an ordinary command, so we don't use an OpenCV function here. So it's then numpy. So the first number is the row number, y. But in OpenCV function, the first number is the column number, or x, because x normally is the horizontal value of the. Oh, there is no sound again. If you hear me, well, please send a plus or 1 or something. I think you should hear me at the moment. Well, yes or no? I think there is a delay until my sound reaches to you and you can answer. Very good, very good. So, if you forget that which one is the first one, or you are not sure, then you can check it. When we write like this, it says all pixels that the first coordinate is 20 and the second is anything. When we put colon here, it means anything, any possible value. So when you see B is 0, G is 0, R is 255. So this is a red color. Okay. So when we run this, you see it's row. It's a row. You see, it's a row. It's row 20. So the first number is the row number, or it's y, because it's the number array. Okay, let's continue. So we can, I told you already that how we can set a value. Of course, you can also change the values one by one. Each channel, for example, you can say img 1, 20, 1, 1, or for example 10. It means the channel 1, okay? Then you should put a one value here. Look, for example, you say 30, then 20, then 1. Then you should put one value. Then you should one value here. Here we put three values because we say that we gave it two numbers, the number of row and the number of column. So because the image is color, it should have three values. But if we give the channel number as well, then of course we should finish the executing of the previous run. Then I run it again, so there is no problem. Of course, I can maybe set each pixel in row 30. The first channel is green, so I put, for example, each green value there 255. You see, it changed the green value, just the green value. So note that previous execution didn't finish, so I press G to finish it. So the pixel values can be modified in the same way. Remember, that is how I explain this. Sometimes you will have to deal with a certain region rather than one pixel. In this case, the ranges of the values should be provided instead of individual values. For example, to get the top left corner of the image, enter the following. So with this command, you see we say img rows from 0 to 50, columns from 0 to 50. So then it's another array, it is another image or another sub-image, or we can say it is a region of interest or a region of the image, or it is a certain region. You see, it is a certain region. We put it in the variable top left corner. Actually, the top left corner is another image, smaller than img, but we can play with it in the same way. Note that when we say from 0 to 50, 50 doesn't include. Okay, let me do it. I'll copy it here. Then I, for example, write it here. Of course, we don't have img, so I change it, for example, img 1, F5. Then I check top left corner shape. You see, it's 50 by 50. So it means that rows are from 0 to 49. The 50 itself doesn't include. This is the convention in Python. The last number in indexing, when we set a range of indexing, when our indexing is a range, the last number doesn't include.